All right, welcome back to the next lesson for the Intro to Processing course here. And so today, what we're going to talk about is how you can make sketches and programs that will actually move and change over time. So it's very cool. Specifically, we're going to talk about using the setup and draw functions. And so that's what we're going to be covering today. And how can we control things? Like, how can we make it so when an event happens, like the mouse is clicked or a button is pressed on the keyboard, that something specifically happens when one of those events happen? So it's going to give us a little bit more control with our programs now. Now, what have we done so far? Well, so far we have drawn kind of static images in processing. We have used variables to make our drawings and things more robust, right? So if you change one dimension or one variable, other variables are maybe related to that original variable. So things will all kind of change in unison. It's almost like dominoes. If you change one domino and it falls, it's going to affect all the other dominoes after it. And so we talked about that, so that's very cool, very good. But still, at this point in time, nothing really changes in our drawings or in our program over time, right? As soon as you click play, it shows something and it just stays there. It's just a still image, it's just kind of sitting there, which is fine, it's just cool. But it would be really, really neat if we could have it where whenever we drew an image, maybe it changed over time, or maybe like a circle followed the mouse or something like that, right? So we could have some fun and do some cool things with that. And so that's what we're going to talk about today. And so let's think about this. How does a program run in processing? Well, I'm actually going to pull up an example that you saw in the variables lecture. So if I pull this up, this should look pretty familiar to you. Have all my wonderful comments here. But all I did here is if I click play, remember I just drew two circles. One of them was right here, one was here, and this one right here is 2 times the size of this. In fact, it's a bit big, so I'm going to change the diameter of this one just so we can better see what's going on. Very cool. And so, but if we think about how this program is run, all it does is it looks at like line 1, and it runs it if there's something there to be run. Then it goes down to line 2. If there's something to be run, it runs it. It just goes on through order through the code and runs it one line at a time. And that kind of makes sense, right? So if we look at this, where these are all comments, so it ignores it, comment, so it ignores it. The first thing it actually runs is line 12 here, where it says, okay, I'm declaring a variable. It's going to be name circle 1x. It's of type int. Cool, it does that. Then it does the same thing for these variables, and then it starts initializing these variables. It gives them some values. Does that in order, right? And then finally it says, okay, let's go ahead and set the size. Let's make the background have a certain color, a color of 30. And if I didn't touch on this before, this should be RGB, right? Where it has 3 numbers. But if you give it just 1, what it does is it just assumes you want that number to be the same for the R, G, and B values. So if that's confusing to you, that's what that does. But anyways, it runs that. It runs this comment. It then draws a circle. And it uses our variables to do that. It then draws a circle after it. So it just runs in order, right? Nothing weird or crazy is happening. The thing is, though, so if you think about most programs that you've experience with, whether it's a video game, whether it's Microsoft Word, whether it's even like a website, YouTube or whatever, right? When you're running this program, it doesn't just sit still, right? And when you click on it and you press keys, it does things. It should do things, right? It doesn't just sit still the whole time. And so that's what we're going to be talking about today. How can we make it where the program will change over time? Sometimes by itself, without us doing anything, it will change. Or maybe if we click on something or if we put our mouse somewhere, maybe something will change as we interact with it as well. That's what we're going to talk about today. Now, this is how programs have been run so far in this course. They just run things in order, pretty straightforward. However, most programs do not run like that. What they instead do is they have different kind of sections, different blocks of code. We'll talk about what a block of code means here in a bit. But they have these different blocks of code. Each block does something different. And then the program will just run whatever block it needs to. And sometimes it'll loop, right? So sometimes it'll do something and then it'll like update itself. So if you think about something like Microsoft Word, it shows certain things on the screen, like it shows the blank document in the toolbar and your cursor and whatever. But what it actually does is it's constantly updating what it's showing. The reason is because if you press a key, it knows, like if I press the A key, it knows it should now show an A on the Word document, right? So then it has to update what it displays. So it's actually always updating what it's displaying kind of constantly throughout the time that it's being run. And so that's very common for a lot of programs. If you think about a video game, what's happening in a video game, you're looking around, you're moving, maybe other elements in the program's moving, right? And so to do that, it actually has to run kind of a display function or something to update and move everything. It has to call that block of code all the time. Just, a lot of times, you hear about frames per second, like 40 frames per second. That means it's calling those functions probably 40 times in 1 second, right? And so we want to start moving towards doing that sort of thing with our programs, right? We can get much more complicated behavior. It can be a lot more fun and cool. And so that's what we want to start moving towards. And so, I mentioned this term block of code. Let's look at what that means more specifically now, right? And so in processing, and same with Java and other Java-based languages, a block of code, it's always written between two curly brackets. So that's this symbol and this symbol right here. You may have never ever used these symbols on your keyboard before, but in coding, you'll start using these a lot. So they're very, very useful. And so you have this left curly brace and this right curly brace. What these do, kind of like parentheses, anything between these two curly braces can be considered one block of code. So it's one block of code that's kind of situated with each other. And I'll show you some more concrete examples of what this looks like in processing here in a few minutes. But an example could be, you want some code to be run with this block. You just have a curly brace, whatever code you want to run for this block, and then another curly brace. Now, there can be many lines between these two curly braces. Don't think that from this example, you can only have like one line. You could have as many as you want. You could have, 5, 6, 1,000,000, 1,000. Who cares? You can have as many lines as you want between those two curly brackets, and whatever is between those two will be considered kind of part of one block of code. This concept will be, we'll talk about this more and more and more throughout the semester. We'll get a lot of practice with this, but this will keep coming back almost every lesson from here on out. And so you'll get a lot of practice with this. Now, let's talk about some very special blocks of codes that already exist in processing. So processing has some built-in blocks of code that we don't have to define, we don't have to make. They're already kind of there. But they're called the setup and draw functions. And so a type of block of code is going to be a function. We'll talk about functions in much greater detail much later in the semester, but they're super helpful and super useful. But there's some already built-in functions called setup and draw. These two functions, the setup and draw function, will help us make programs that will change over time, that will respond to our inputs and things like that. And so we're going to talk a lot about those today. Now, let's talk about them kind of in the abstract and, conceptually first, and then we'll start jumping into code and what it looks like and how to type it up, all that good stuff. But first, let's talk about the concept behind these. We'll start with the setup. So what is the setup function? Well, the setup function, remember, it's a block of code, so it's going to have two curly braces associated with it, right? And so the setup function, that block of code is going to run only once in your program. And it's going to run before the draw. It's going to be run at the very beginning of your program. So it's run only once and at the very beginning of your program. So, what use is that? Why would we use something like that? Well, it's really good to initialize things in your program. So maybe like we've initialized variables now, maybe if you want to initialize some variables, you would tend to do that in the setup because it just runs at the very beginning, it runs it once, and so it just says, hey, for now, at the beginning of my program, just set these variables equal to whatever value you want. It sets it up for you. And I have a more concrete example here in the next slide, which is Pong. So if we think about the game Pong, if you don't know what Pong is, it's a very old video game back in the 80s, right, where you have two players. One player controls this rectangle. They can move it up and down. The other player moves that rectangle. They can move it up and down. And you can see they have it's a ball, and you basically play tennis or ping pong, right? That's why it's called Pong. It's like ping pong. And so you can move it up, and that ball is going to move, and it bounces off these walls. And if it gets past a player, then the other player gets a point. And so you can see that's the score here. So this player has 4 for their score. This player has 2 for their score. And so, it's just very simple games, basically ping pong, but it's a video game. But if we think about this, what are some things we maybe would want to initialize in Pong if we were going to make Pong ourselves? What kinds of things would we initialize? I'll give you a second to think about that. And so, now we can just go over it. Some things you may want to initialize is, let's think about what things should be set at the beginning and only once at the very beginning. Well, probably the score, right? We probably want to set the score where both players have a score of 0. We initialize the scores to be 0. We probably want to set the position of the scores, right? Because that won't change over time. We can go ahead and just set them as constants. So we can just say, hey, put the player 1 score at that position, whatever it is. Put the player 2 score at this position, whatever it is, right? We also maybe want to initialize the position of the ball. You probably want to initialize it at the center of the screen, right? And so that would be another thing that would be put in your setup function. The position of the ball, the size of the ball, things like that. And other things like maybe the positions of the players, maybe the speeds that the players can move, that type of thing. And so kind of all the settings that you'd want to set up at the beginning of your program, you would put inside that setup function. And so hopefully that makes sense. Let's now talk about the draw function. So what does the draw function do? How is it different from the setup? Well, it's also a block of code. So it has 2 curly braces, and then has some code between those 2 curly braces. Except for draw, the code between those 2 curly braces will be run forever. What I mean by that is that it loops. It's going to loop, right? And so it's going to start at the beginning of draw. It'll run through line by line by line until it gets to the end. Once it reaches the end of draw, it actually starts back over and just keeps on going forever and ever and ever. And we can tell it to stop, but you almost never do. You just kind of let it loop until you close the program. So why is that useful? Why is this kind of infinite looping thing useful to us? Well, it's really good for doing things where we want to constantly update something in our program. And so kind of like I was saying, Microsoft Word, whenever you type, it responds to whatever you type and then updates what it displays. There's some kind of update function in Microsoft Word in the program used to make it, or a display function, something like that, so that every frame it's going to update what it's displaying on the screen. Draw function is going to play the same role for us, where it's going to constantly be updating things. And, whenever something should be changing, it will change that for us because it's running, 40 times a second or whatever it is. And so this is really useful for things that need to constantly update or for things that are going to change over time. And so if we think back to our Pong example, what kinds of things do you think should be updated kind of constantly over time? So I'll give you a second to think about that. And okay, and so some things that, should be updated every frame, pretty constantly over time could be things like the score, like the value of the score, right? So you want to always update that. Maybe it won't change, right? Maybe it's still 0 and you check again, oh, it's still 0, or it should still be 0. But at some point in time, the ball is going to reach the end of the screen. When that happens, you need to be ready to update the score. And so that could be something that you would kind of constantly check and update. Another thing could be the position of the ball, because the ball should be moving, right? It should be always moving pretty much. And so the movement of the ball would be controlled by the draw function. It's going to always be saying, hey, move the ball, move the ball, move the ball, move the ball. Same thing with the players, maybe, right? Because the players they're playing, they're pressing the keys, moving the players up and down. Well, you need to be prepared to always be moving those players whenever the player presses a key. So the draw function will handle that for us as well. And so hopefully that makes sense. That's kind of conceptually what they do. Let's now start talking about how we actually implement those 2 things, the setup and draw function in code. And so I have a picture here of what they look like, and then after this we'll jump straight into processing and just play with it, right? And so if we look at it though, whenever the setup or the process of writing these, the syntax for writing the setup and draw functions is you always need to have the word void before it. There's a reason for this. Do not worry about it right now. We will talk about this in a number of lessons from now. At this point in time, it's just some magic word that we have to put there, right? It will not work if we don't have it, so we have to put it. But for the moment, don't worry about what void does. That will be covered in a future lesson. But you do have to put in the word void. And then if you want to do your setup function, you have to type in the word setup, and then 2 parentheses. Turns out you always need parentheses if you're having a function. We'll talk about that again in a future lesson. But setup, open parentheses, close parentheses. Nothing needs to be in it. It can just be closed. In fact, it should be nothing inside those 2 parentheses. And then finally, our curly brace. So what I tend to do, there's different ways of doing this, but you would have a curly brace right after setup. Then you have whatever code you want to be part of that block of code, be part of your setup function, and then another curly brace to close it off. And so that's the basic structure. Draw is the exact same thing, except you would have draw instead of setup. So you have your void, you type in draw, you have your 2 parentheses, nothing in between them. You have your curly brace, your closing curly brace, and whatever code you want to be part of draw would be here between it. And so let's step away from the slides, right? Because, I mean, as cool as slides are, what good is it, you know? If we want to learn to code, we got to actually code, right? And so I have a blank example here. So, you know, I'll even delete this. We'll type it up together. I encourage you to follow along if you'd like to. And so what we want to do is we want to go ahead and make a setup and draw function. And so what do we need to do? Well, as we just learned, the first thing we need is type in void. Again, that's a magic word. We just have to have it for right now. And then for setup, we type in setup, parentheses, open and closed. You see, as soon as I add these parentheses, setup turned blue. So processing is saying, hey, I recognize this thing. I know what this is. You know, it's already been defined for us in processing. Then we're going to put a curly brace there. That's going to be, you know, an open curly brace. I always like to go down a few lines to give me some space and then do my closing curly brace. Then I can type in whatever code I want right here, and it will be run as part of my setup function. Let's go ahead and set up our draw as well. So I'm going to go down here, say void, draw, parentheses, and my 2 curly braces. There's my draw. Same setup, or same syntax as the setup function. Now, let's see how these work. So, you know, if we mess around with this, we know setup should run before draw and should run only once at the beginning. So let's play with that. If I say print line, setup function was run. You know, I'm going to print that out here in my setup function. So whenever the setup function runs, this should run this line of code, right? And so I'm going to leave draw blank for now. Let's see what happens. If I click play, nothing happens in my window. That's fine. I didn't tell it to. But you see it says setup function was run. Cool. Alrighty. Now let's do something very similar for the draw, except I'm going to just copy this line of code right here. And something I want to point out, it ran only once, right? So we said setup function should run only once, and that's what we see here. We only see the output done once. Now what I want to do is print something else here in the draw function. This I'm going to just say print out the message draw function was run. And let's press play. Let's see what happens. So I press play. I'm going to scoot that over. Oh, I can't scoot it over right now. But you see, ooh, I don't know if you can see right here. You see this bar? If I scroll it up, it just goes back down. That's because it's saying draw function was run. It's running the draw over and over and over and over again. So what's happening is that this message, you know, whenever draws run, this message is being printed out, and it's running. I think processing tries to do 30 frames per second, and so it's printing this out actually 30 times per second. So I'm actually going to click stop. In fact, I don't think I can go back to the top. Too many times it was run, right? But you can see this was run many, many, many times. What I'm going to do, I'm going to press play and then stop it like right away so we don't get too many messages. Stop. So if I go up to the top of this, you can see what ran first. Well, my setup message ran. Setup function was run. And so what we're seeing here is that the setup function runs before draw, but the setup function only runs once, and then it's never ran ever again. But for the draw function, after the setup, it starts running, and then it just runs over and over and over and over until you stop your program from running. And so hopefully that makes sense, both in terms of how you write the setup and draw function, and also kind of how, you know, the logic behind how they operate. And so let's continue on from there. And so, you know what? Let's actually go back and let's start drawing some things, right? So we're printing messages here, but let's do some setup and some drawing stuff, right? And so I'm going to make some variables. You tend to declare variables before your setup. So that's actually a good note to have, declaring variables. So you can put things outside your setup and draw. You don't have to put everything between these two, right? You can still have things outside. You tend to declare variables before your setup, but you tend to initialize your variables. In other words, give your variables some values inside your setup function. And so let's say I just want to draw a circle, right? What kind of variables would I need to draw a circle? Well, I need 3 different things to make a circle. I need the x position, the y position, and the diameter. So I'm just going to make some of those. Circle x, int circle y, and then int circle d for diameter. I'm going to initialize these, going to give them some values in my setup. I'm going to say circle x is equal to, I don't know. Oh. Well, you know what? I'm going to go ahead and continue, and then we'll make a note about this in a second. But let's say, I don't know, 200. Who cares, right? Circle y equals 200, and then the circle diameter, I'm going to go ahead and say 100. Sure. Now, I need to also, if I want to draw something, you know, if I bring up the example from the variables, right? You know, what's something we always need to include as we draw something? Well, we always need to say what the size of the window should be, right? Otherwise, the window's going to be very small. We can't see anything usually. So we need to say the size of our window. So a question I have for you, the dear listener, is where should I put this size function? Should I put it, you know, am I declaring it? Is that a variable I'm declaring? Is it something that should be run once at the beginning? Or should it be something that, you know, I update every frame? So I'll give you a second to think about that. And well, the answer is size. We don't want the size to ever change as we run our program. The size always stays constant. And so what we need to do is not a variable we're declaring, but since it's something we want to kind of set up once at the beginning of our program, I'm actually going to make my size here in the setup function. And so I'm going to say, you know, size setup. So for my size, I'm going to say size parentheses. I'm going to make it maybe 800, well, 1200 wide, 800 tall for me. You know, these dimensions may not work for your screen resolution. You know, you have to play with it. But I'm going to do this. Press play real quick just to see. Yeah, that's a pretty fair size for me. It's big, but not too big. Okay. Now I have these here, these variables. And now I want to draw a circle. So where should I draw it? Should I draw it in my setup or should I draw it in my draw? Well, maybe by the name, you're thinking, oh, I should draw it in my draw. That kind of makes sense to me too, by the name. We'll talk about here in a few minutes about why that makes sense. I'll give you some more examples. But let's say I'm going to draw it here. Circle, and then what do I put inside for my circle function? I'm going to say circle x, circle y, circle d, boop, boop, something like that. First off, let's go ahead and press play. Let's see what happens here. Press play. There's my circle. It's there. Now here's the thing. What if I wanted to put this in my setup? If I, cut that, put it in my setup, will we see anything different? Well, press play. It doesn't look any different. It's weird, right? There's nothing, so what's the point of having these, right? They do the same thing, or at least it looks like they do the same thing. Well, that's going to be my next question for you, is let's say you want the circle to get bigger over time. How can we make this happen? Well, what we can do, what's the, in fact, I have R here. I'm going to call it D for diameter. What we can do is we could say, hey, just make the diameter equal to itself plus 1. So that's something you can do, that if you, what this line is right here is saying, hey, you have a variable called D that's saying, hey, make D equal to itself, whatever it is, but 1 higher. So what this would do is that if D starts off at 5, when this is run, D is going to be equal to itself, which is 5 plus 1, so 6. So D was 5 and becomes equal to 6. If you run that line of code again, it will become 7. You run it again, it becomes 8, so on and so forth. Now, a question I have is, let's say we want D, our diameter, to increase every frame, right? Well, how could we do that? Where should we put that? But we know we need something of this structure, but where should we put that if we want to update every frame? Well, we're going to put that in our draw, right? And so what, if we're going to make the diameter increase, what variable do we use? Well, we'll use our circle D variable, because that's the variable that controls the diameter of our circle. So if I say circle D equals circle D plus 1, let's say, that should update the diameter of my circle, right? So maybe since draw runs over and over and over again, just like these messages down here were just running over and over and over again, this line of code right here is going to run over and over and over again. So we should see the circle have a bigger diameter over time, right? And so let's press play and see what happens. And it's not changing. Nothing's happening. Why is that? Why do you think nothing's changing? Because we know, in fact, I can even see right now, it started printing again. This line kept running and running and running and running, right? It's running over and over again. So this line must be running over and over and over again, but we're not seeing any change in our circle. So I'll give you a second to think about why that is. Okay, so hopefully you had a chance to think about that. And so if we think about this, processing does not draw anything unless it won't draw the circle unless we call the circle function. And let's see, where do we call that circle function? Well, right now, that's in our setup. And what does setup do? Well, it's run only once at the beginning of my program. So that means it drew a circle once at the beginning, and then in the draw, it updated circle D, but it never tried to draw the circle again. Because the circle, it was drawn once at the beginning, but here in the draw, it never tried to redraw it. So even though it changed the value of the variable, it never redrew the circle with that new value. So what we need to do, and this is why draw is useful to us, what we need to do is instead of drawing the circle in our setup, I'm going to cut it again, put it back here in my draw, and now let's see what happens. Look at that. I press play. It started off at that initial size. Now it's getting bigger and bigger and bigger. And it turns out, since I didn't put any limit on it, it's going to just keep getting bigger and bigger on until forever, which is kind of cool. And of course, what's also cool, I had +1. Let's say we want it to get bigger even faster. I can change that +1 to a +10. So it gets bigger by 10 pixels every frame instead of by 1. So this should be 10 times faster. Let's see. Whew. There we go, 10 times faster, and boop, it overtook my screen. So that's pretty cool. But hopefully that kind of makes sense, right? So it does matter what you put into the setup and what you put in the draw, right? If you put something in the setup, it's only going to run once. So if I put this circle command in my setup instead of my draw, it's only going to draw that circle once at the beginning. And even though my diameter is changing, my diameter variable is changing, I never redrew the circle with that value, so I don't see any change. So hopefully that makes sense to you. I'm going to take that, do this, put it back in here. So hopefully that's been pretty cool for you and pretty interesting. Alrighty, now let's continue on. I now want to talk about some other variables that are built into processing that will also allow us to kind of move things and have some fun with them. So earlier we talked about, in the last lesson, we talked about variables and how we can make variables. We also talked about some built-in variables, specifically the width variable and the height variable, where there's some other built-in variables in processing. So we don't have to define them. Processing already has them defined, and they're built in, but they can be really, really useful for us, and we're going to make use of them today. These two variables are the mouse X and the mouse Y variables. Notice that they're defined in camel case, so mouse and then X is the next kind of word, and so it's capitalized, mouse X, mouse Y. These two variables, they're always equal to the position of the mouse. So mouse X is always equal to the X position of the mouse. So as I move my mouse left and right, the X value of that mouse is changing. So whatever the X value of that mouse is, that's what mouse X is equal to. Mouse Y is the same thing. It's going to be equal to the Y value of my mouse. So as I move the mouse up and down, it will be equal to that value. And so let's play with that. Let's go back to our little circle thing here. So if we press play, right now it's still getting bigger. I'm going to get rid of that. So I'm going to comment out this line of code so it doesn't run. So if we press play, You see, now it doesn't run that line of code anymore. But now what I want to do is make the circle follow my mouse. So if I want it to follow my mouse, that means I want the X position and Y position of my circle to match the X position and Y position of my mouse. So how could I do that? So I'll give you a chance to think about that. Well, what I can do is I can just go here, and for my circle X, instead of having circle X, I can just say something like mouse X. So now what this means is that whenever I move my mouse, the circle should have the same X value. Press play. Let's try that. Oh, whoa, and something weird is happening too. What is that? Let's get this weird worm thing. I mean, we can kind of see what's going on, right? Where the circle is, as I move my mouse, it follows me. But the problem is we can see all the previous circles as well. Oh, that's a bit weird and freaky. We'll talk about that here in a second. Let's go ahead and make it where it also follows our Y value as well. How do we do that? Well, it's going to be the same thing. Instead of using our variable, we're going to use the built-in variable, mouse Y. So now the circle should have the same X and the same Y value as our mouse. Press play. If I move it, you see it's following my mouse, but we're getting this weird worm-looking thing. Ooh, it's a bit freaky, right? Ooh. It's kind of cool, though. And kind of paint a little bit. But what's happening here is that it's moving, right? It's following my mouse, but we're also seeing every previous circle that it's drawn before it. And so that's not really what we want here. We just want the circle to move. We don't want to see every other previous circle because we don't want this weird worm-looking thing, right? And so what's going on? And so first off, before we talk about how to solve this, let's think about what's happening. Remember, processing is now drawing a circle every frame, right? Because if I bring up my code, it runs this line every frame. So what that means is going to draw a circle every frame, and it's going to try to do that, I think, 30 times a second. And so even as I move, it draws a circle, and if I move it, it draws a new circle, but I can still see the old drawing. And so all it's doing is it's going to draw circles on top of circles on top of circles until I move it, and then we can see kind of what's, what was left from our previous drawings. And so we don't want this. What we kind of want to do is we only want to see the most recent version of our circle, and we want to kind of cover up, hide away all those previous circles. So how can we do that? How can we cover everything in our window? How can we just wipe everything, just kind of color over it so we don't see any of the old things? Do you remember a function that we have talked about this already in a previous lesson? Is there anything that you can remember? Well, maybe you thought about the background function. So the background function, of course, what does it do? It just paints a color over the whole kind of background of the window. So what this can do is it can actually cover over all the previous drawings of our circle. So let's do that. Let's say I want like a light blue. So you know what? I'm going to have some fun. I'm going to do it with my color selector. I want like this kind of blue, something like that. So no red, 214 and 240. Okay, cool. So no red, it was like 214 and then 240, something like that. Like a nice little teal. So I'm going to do that. So what does it draw to? Prints the message, who cares? It draws the background and then it draws the circle. Let's press play. Let's see what happens. Look at this. So what's happening, it's just drawing a circle every frame. But because it runs so fast, it's almost like a flip book, right? If you do a flip book and you flip through it really quickly, it looks like things are moving. Really, they're not. It's just a bunch of still images. But it looks like movement, right? Same thing here. It's drawing circles so fast that as I move my mouse, it's drawing a circle at a new position that's just a little bit off. So we get the illusion of movement here. And so what the background function is doing is, it runs at the beginning of draw. So what it does is if I drew a circle, it then covers it over with the background, and then it draws a circle back on top of it. And that's this most recent circle that I see. It then starts back over, calls background, so it wipes everything clean, then it draws the new circle, and just does that over and over and over again, so that it looks like my circle is moving, following my mouse, which is pretty dang cool. I like that. Woo. Now, the question I have is, what happens? I put the background up here before the circle. If you remember from the variables lesson, we talked about how order matters. if I take background and put it down here and press play, what happens? Well, where's I don't see my circle anymore. Oh no, what the heck? That's not what I'm looking for, right? That kind of sucks. And so why is that? Why do you think this is happening? Oh, I saw it. Oh, that's weird. We saw it for a second. But why am I not seeing my circle anymore? Why did just putting my background at the bottom of my draw after circle, how did that change things? Well, what's happening is, remember, order matters. So if we think about what happens is, draw, what it shows you, it only shows you the stuff, at the end of draw, that's when it displays. That's when it shows you. It does all its figuring about what it should show first, and then at the end of draw, it shows it to you. So what it's doing is it draws the circle, but then immediately after it draws the circle, it covers over it with the background. And then that's what it shows you. So it is drawing the circle, but it's just immediately painting over it with the background, so we never see the circle because the background's always on top of it. And so that's not what we want. We always want the background to be at the top of our draw. And then when we press play, now we can see it does the background first and then the circle, so we can see the circle kind of on top of our background. So hopefully that makes sense. Let's see, let me plug in my computer here, getting a bit low. And so that is kind of the benefit of the setup and draw functions, right? And so they allow us to have programs that can move and change over time, as well as respond to us, because as I'm moving my mouse, it's responding to me and kind of doing cool things and changing. Now, I have one last kind of concept I want to talk about, and that is the mousePressed and keyPressed functions. These are also built-in functions, just like setup and draw, but they do something a little bit different from setup and draw. So since they're functions, they're also blocks of code. They have their curly braces. But what happens is the mousePressed function, it runs its blocks of code once whenever you click the mouse. Whenever you press down on your mouse, this function runs once. The keyPressed function does the same thing, except it runs once whenever I press a key on my keyboard. It will run exactly once. So this is useful for kind of changing things in my program. So whenever I press something, it will react to that. So whenever I click my mouse, it reacts, and it will run whatever I have inside my mousePressed function. Or if I press a key, it will run whatever is in my keyPressed function. And so what kind of syntax is that? So I have just a brief example here. It's very, very, very similar to setup and draw. I have my void. But instead of saying setup or draw, I have mousePressed in camel case, parentheses, you've seen that before, curly brace, and then I have whatever code I want to run whenever I press the mouse. And same thing for keyPressed, except I have the words keyPressed instead of mousePressed. Now, what this does, if we look at this, what does this do? It actually just changes the background color. So whenever if I put this, I'm going to actually put this in my sketch here in a second, but whenever I press the mouse, it's going to change the background to be, let's see, green and blue. I'm forgetting my color theory. What is that? It's not yellow. That's red and green. Not like a purple? I don't know. It changes to whatever color that is. And it's also going to put the message mouse is pressed. The keyPressed function, whenever you press a key, it's going to change the background to blue and then print out the message key was pressed. And so let's play with that and let's see what it does. And so I'm actually just going to add that to here. What I'm going to do, I'm going to stop printing these messages for my setup and draw. And I'm going to go down here below my draw. You don't want to put mousePressed inside your draw. So when I mean inside the two curly braces. I want to go after that and say void mousePressed. And then, do some bracket stuff. I'm going to do a message here. Print line mouse was pressed, just so I know. And then I'm going to change the background color to, I'll do the same color that I had in my example. And while we're here, I'm going to go ahead and say void keyPressed, parentheses, bracket, and then print line key was pressed, semicolon, and then change the background to, let's do pink. Background to pink, which is maximum red, no green, maximum blue. There's a cool perception reason why that is, but we won't talk about that right now. And so, yeah, let's run this. It should have the same thing where it draws a circle and it follows the mouse. But it should also be whenever we press the mouse, we should see this message. It should change the background color. And whenever we press a key, any key on our keyboard, it should print this message and change the background color to pink. So let's press play here. Cool. So same thing. I can move my circle around. I'm going to move this kind of over here. If I click my mouse, oh, look at that. Oh, yeah. So it says mouse is pressed, and we see a flash in the background, but it doesn't stay. It goes right back to blue. Why is that? Why does it not? You know, we told it to be the background here, to be whatever color that is. Why do we not see it? So if we go back to our code, let's think about this. mousePressed, remember, is run only once whenever we click the mouse, and we know it's running because it's giving us this message, you know, that we told it to give us. But what's happening is that since that's run only once, it changes the background. But after it calls mousePressed, we see it for one frame, but then it immediately goes back to draw and it runs draw over and over and over again. Well, it changes it right back to blue. And so even though we changed it to be that color, it went right back to blue. And so that's actually messing us up a little bit. So what I'm going to do is I'm actually going to put this blue background in setup, where we set it once in the setup function. It's going to be a bit weird, but we'll see this. So you can see right now I'm still getting this worm thing, but when I click the mouse, it changes it. Oh, it's like the teal. It's the same teal. So okay, I'm actually going to make the mousePressed color a little bit different. I'm going to have it be just green. So mousePressed background's green, keyPressed is pink. So we start off there. Now, because we took it out of draw, it's not updating, right? But when I click the mouse, it turns to green. Ooh, and then I can move around, same kind of thing. Press pink, or press a key, it turns to pink. You know, pressing keys. If I look, it's my messages. Yeah, key. And so you can see this allows us to control different things with a keyPressed and the mousePressed thing, right? And so what we can do is, well, we can do anything we want. So let's say we change our circle diameter. Our circle D is going to be equal to, let's say, 200 here, semicolon. And then circle D here could be equal to, I don't know, 50. Make it small. What I'm going to do, I'm going to put this background, this blue background that was in my setup, I'm going to put it back in my draw for now. We'll talk about how we can dynamically change the background using keys and stuff later on. But now what mousePressed and keyPressed will do is it will change the size of the circle instead of the background color. So let's play with that. Press play. Okay, if I press a key, 50, so I made it smaller. If I press the mouse, bigger. Small, big, small, big, and it still follows my mouse. So we can now kind of have some cool control here. Pretty neat. And so, yeah, so that's that. And I think that's actually the last thing I wanted to cover. And so hopefully that all makes sense. A challenge I have for you to kind of mess with all of these is, you know, we had it where the circle automatically got bigger on its own. What I want you to do is draw a circle in processing, make it so that the circle starts at the top of the window, and it automatically, without you doing anything, it starts to fall. Have it just automatically fall by itself from the top to the bottom. And make it so that whenever you click the mouse, it starts back to the top. So whenever you click the mouse, you know, the circle's there and it's falling. Whenever you click the mouse, you should stop back to the top. And then you should also make it where the color of the circle changes whenever the key is pressed. So not the background color, but the color of the circle. The hint is that you may want to use a color variable or something like that. So whenever you press the key, you would change the color variable. And so I'm going to give that as a challenge to kind of mess with. I can even show you what the solution looks like. Not the code so much. There's some variables and stuff. You don't have to have these, but what it should look like, you can see I have a circle. Whenever I click the mouse, it starts back, goes to the top, click, goes to the top, click, goes to the top, click, goes to the top. Whenever I press a key, changes the color of the circle. So here, let me start that over so you can see it happen as it falls. Press a key, does that, and it permanently changes the color.
And so that's actually kind of combining all the concepts we've learned today. And so I encourage you to give that a shot and see if you can get that to work. And so that being said, that's all I have for you. Thank you so much for joining me for today. And I hope this was helpful to you.